Hello and welcome to a video on isosceles triangles. So we're going to develop theorems about isosceles triangle and we're going to prove them and use them. So let's move on. So some of the triangles Jason needs to replace are isosceles triangles. So remember in our last lesson Jason was replacing the glass triangular stuff on the outside of that little shape thing building. Okay. So he needs to know what an isosceles triangle is and wants to be sure he's correct. So let's talk about isosceles triangles. So you've seen it before in middle school. The name isosceles is derived from the Greek iso, meaning same, and scales, meaning leg. So same legs, okay? So define an isosceles triangle. Here is the definition. So an isosceles triangle is a triangle with at least two sides congruent. So if it has two of the same sides, it is isosceles, okay? How we mark that is same side, so with the side tick marks, okay? Now we're gonna label our triangle down here. So it wants us to classify and label each side and angle using the term vertex angle, base angle, leg, and base. So the vertex angle, vertex is the peak of something, so it's the top. So this angle up here is your vertex angle. Okay, so where the two sides that are congruent meet up is the vertex angle. Okay, that means these angles down here are base angles, and the sides opposite, or the angles opposite of the sides, are congruent. Okay, so for example, this side is facing this angle, and this side is facing this angle. So these are your base angles. Okay, so in an isosceles triangle, the two bottom ones are your base angles, and then the tippy top where the two congruent sides meet is called the vertex angle. Okay, let's label our sides now. So we have legs and we have bases. So the bottom one is your base, and then the two tick marks are going to be your legs. So leg and your leg. Okay. So that is an isosceles triangle and all the vocabulary words that you need to know, okay? So let me know if you have any questions on that. But what appears to be true about the base angles of an isosceles triangle, okay? They have the same tick marks, okay? They kind of look the same, and they are the same, okay? So we're going to write an if-then statement known as the isosceles triangle theorem, okay? So if something, then something. So, if a triangle is isosceles, then the base angles are congruent, okay? So if a triangle is isosceles, meaning that it has at least two sides the same, then I know the base angles are congruent, okay? So I'll give you a second to write that down. So again, the base angles are opposite of the sides. So for example, here is this tick mark, here is the angle opposite, okay? So the base angles are located opposite of the side. All right. Let me know if you have any questions on the isosceles triangle theorem. Otherwise, we're going to look at a proof of why it exists. All right, so I have a proof to my left. So it says the proof of an isosceles triangle theorem begins by drawing the bisector of the vertex angle. Okay, so what I have to do is I'm going to draw a line straight down from B and create an angle bisector. So let's do that with me. It's a really terrible thing. Okay, so I'm going to start my proof off by drawing. I'm going to erase that. That's terrible. We're going to get the line tool out. Okay, I'm going to drop down an angle. Boom, that looks way better. Okay. All right, so let's talk about this proof. If ABC is isosceles, I know that AB, they gave me a tick mark here, is equal to CB. So that's given. They gave that to us in our picture, okay? The reason I know ABM, okay, where this bisector hits, I'm going to call it M, by the way. So ABM is this angle here. The reason I know that this angle is the same as this angle is we drew that bisector line, so that's the definition of an angle bisector. Okay. The reason I know that BM is congruent to BM, that'd be this mark in the middle, that's the reflexive property. Okay. The reason I know triangles are congruent, so that's the side, 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 angle, stuff we learned. I have a side, and then an angle, and then a side. So that would be side, angle, side. And then the reason I know that angle C is congruent to angle A is right after that would be CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so here is why my two base angles are the same given this proof. Okay, so if I know a triangle is isosceles, then I know its two base angles are the same. Okay, so we have proved that the corresponding parts of congruent triangles are congruent, and that's why it exists. How cool. Okay, all right, let me know if you have any questions on why we are allowed to prove base angles are the same in isosceles triangle. Otherwise, we're going to move on to some practice. All right, so the measure of a vertex angle of an isosceles triangle is 80 degrees. What is the measure of the base angle? So first, we're going to draw a picture because that's going to help us out. So vertex angle, remember, is the tippy top angle. So I have this, okay? Vertex angle is going to be 80. So this top part in the inside is 80, and if it's an isosceles triangle, I know the two sides that meet up with the vertex are congruent, okay? So I'm trying to find the base angles, okay, which I already know base angles have to be the same, okay? So there are two ways of doing this. I'm going to teach you the shortcut way first. So we know a triangle equals 180 degrees. So start with 180. I know the vertex angle is 80, so I'm going to take that away and see what's left over. So 180 minus 80 is 100 degrees. Okay, so I have 100 degrees to split evenly between two things. So I'm going to divide up 100 evenly between you and me. And so that's dividing it by 2 to get 50. Okay, so I know my base angles both have to be 50. That makes sense because 50 plus 50 is 100 plus 80 is 180. So that works out. Okay, now if you wanted to do it the algebraic way, I know my base angles are the same. I don't know what they are, so I can call them x. Okay, so then you could write an equation of a triangle and say x plus 80 equals 180 using our triangle sum theorem. Solving this is going to get you the exact same thing of 2x equals 100 divided by 2, and you're still going to get 50. Okay, so you can pick if you want to do it the algebraic way, you can, or you can kind of use some problem solving skills. If I know the top angle is 80, I'm going to subtract it to see what's remaining, and then I know these have to be the same, so divide it by 2. Okay, so if you know the vertex angle and you're finding the bases, you're always going to divide by 2. Okay, all right, I'm going to erase this red real quick. All right, let's take a look at another example. The measure of one base angle of an isosceles triangle is 25. What is the vertex? Okay, so on these, they only have to give you one number. So let's draw a picture. It's an isosceles triangle. I always draw it right side up to help me out. So the base angles are your bottom ones. One of them is 25, and I'm trying to find the vertex angle. Okay, well, I know base angles are always the same, so I can go ahead and copy and paste that 25 over, and then I have two measurements of angles of a triangle, and I'm trying to find the third. So I know triangles have to add up to 180. I'm going to take away what I know, which was 25 and 25. So 180 take away 50 is 130. Okay, so that has to be the vertex part of my triangle. Okay, again, you could do this in algebraic way if you wanted to. If I don't know the top, I can call it x. So then I could say 25 plus 25 plus x, because all the angles of a triangle are going to add up to 180. 50 plus x equals 180. And again, you still get the same answer doing it the algebraic way. Okay, we're just kind of doing one part in our head. You can do one part physically, mathematically. Okay, So let's kind of overview that. If you know the vertex angle on number 4, we subtracted it and divided it. If you know the base angles, you're copying it or duplicating it or multiplying it by 2 and then subtracting it from 180. Okay? And those are your two kind of options. They're either going to have to give you the base or they're going to have to give you the vertex angle. Okay? All right, let's take a look at some more trickier problems because they give us more variables. Okay? Move my face. All right. So number 6, I want to solve for x. The reason I know it's an isosceles triangle is because I have two legs that are the same. So I have this 5 and this 5, meaning that my legs are the same. So I'm going to go ahead and mark my base angles. So opposite of this red side is over here. The opposite of this side is over here. So these are my two base angles, meaning that this up here is my vertex. Okay? So I need to find this missing angle, and if I know these are the same, I can go ahead and copy and paste it over. So if they're the same, this one's also going to be 2x plus 3. So now I know all the measures of my inside of my triangle, so I can use my triangle sum theorem to solve for x. So let's do that. So I'm going to say 3x minus 1 plus my other angle 2x plus 3 plus my other angle 2x plus 3, I'm going to move my face, equals 180. Okay, so all three of your angles added together equal 180. I'm going to add like terms now. So 3x, 2x, and 2x, 3, 4, 5, 6, 7x. 3 and a 3 is 6, minus a 1 is going to be 5. Okay, so combining your like terms, I'm going to subtract 5 now. 7x equals 175. Divide by 7, I don't know what that is. 175 divided by 7 is 25. So x is 25. Okay, and I'm done because it wanted me to solve for x. If it said find the base angle, I would be substituting in my value for x. Okay, so let's check it for the heck of it to see if we're correct. So if I substituted in here, 2 times 25 is 50, plus 3 is 53. So my base angles are both 53 degrees. Let's plug it into the top, substitute it. 25 times 3 is 75. Minus 4, minus 1 is 74. So then let's check that out. If I add this angle and this angle and this angle, I better get 180 degrees. So 53 plus 53 plus 74. It worked out. I got it right. Okay? So if you're ever on a quiz and you want to make sure you're correct, you can always substitute your answer in to find your angle measurements to see if you're right. All right. So that's an example of how using algebra and isosceles triangles. Okay? All right. Let's look at one more proof problem. Goodbye, face. All right. So look at the rainbow right there. Okay, using the figure below, I know that PQ is congruent to PR, and I know TQ is congruent to TR. Okay, go ahead and press pause and see if you can try these reasons. Okay, it kind of goes back to module 1, so substitution property comes back, maybe transitive property, maybe angle addition property, those kind of come back. Okay, so see if you can try these on your own, and then we'll go over them. So press pause and give it a shot. All right, before we go over the answer, I'm going to read this connection to history real quick because I think it's so interesting, and it basically says this was a really hard proof. Okay, so connection to history, Euclid's proof of the isosceles triangle theorem, which we're about to do, is given as the 5th proposition in Euclid's book of the Elements. Is somewhat subtle and has been given the nickname Pons Asinorum, Latin for bridges of asses. Okay, the two reasons why this proposition earned its name are: 1, Euclid's diagram for this theorem looks like a bridge. Okay, This kind of looks like a drawbridge, going up and going down. Okay. Second, this was the first proposition that tested students' ability to understand more advanced concepts in Euclidean geometry. Okay, so this proof was to test students' ability to understand advanced mathematics. Okay, therefore, this proposition served as a bridge from the trivial portion of Euclidean geometry to the non-trivial portion, aka the people who could not cross this bridge were considered unintelligent. What? So like if you didn't understand this proof back in the old days, you were considered unintelligent. Well, anyway, okay, let's talk about it. So they gave me number 1, so that is a given. Okay, I'm actually going to go ahead and mark it. All right, PQ, this side. PR, this side. I'm going to switch colors real quick. And then TQ, this side. TR, that side. So they've given me this, okay? That looks like an isosceles triangle, correct? So the reason I know that PQR, which is all of Q, is equal to PRQ is because that's a definition of isosceles. So it's the isosceles triangle theorem. If you put definition of isosceles triangle, that's good too. Okay? So if this is an isosceles triangle, I know their base angles are the same. Okay? All right. Next but not least, it says PQR. So this left angle is equal to the measure of angle 1 plus the measure of angle 3. Okay? Same thing over here. PRQ is the measure of angle 2 plus the measure of angle 4. That's the angle addition postulate. Back to module 1. This total is equal to part plus part. Okay? Now you have to kind of look and see what happened. So here's my blue side, and here's my green side. So notice the blue side went to the left-hand side. The green side went to the right-hand side, okay? Because up here, I knew that this was equal to this, so they just took the blue side, put it in place of it, took the green side, put it on the right, okay? So based off that, that is a substitution property, okay? If I know they're equal to each other, I know what they add up to is also equal. So measure of angle 1 plus measure of angle 3 is then equal to measure of angle 2 plus measure of angle 4. Okay? Now, I know that angle 3 is congruent to angle 4 because here is a smaller isosceles triangle. So that's, again, the isosceles triangle theorem. I know my two base angles are the same. Okay? So now, I'm doing red this time. See angle 3 here and angle 4 here. Well, if they're the same, they're just going to say, well, hey, angle 4 becomes an angle 3. Okay? So if they're the same, I can substitute them in for another. So that'd be the substitution property. Okay? So now they dropped down angle 1. They dropped down angle 3. They dropped down angle 2, and they replaced angle 4 with an angle 3 because they're the same. Okay? Last but not least, they subtracted angle 3 from both sides. Goodbye, angle 3 from both sides. That'll cancel and cancel, leaving you with the measure of 1 equals the measure of 2. So 1 is congruent to 2 based on subtraction property of equality. Okay? Crazy proof, right? And back in the old days, they said you were unintelligent. How dare they? All right. Let me know if you have any questions on that. That is a pretty tricky proof. But we're going to move on. All right, last one, and then you're going to do a little check your understanding. So write the converse of the isosceles triangle theorem and determine whether it will always be true. If yes, explain. If no, give me a counterexample. So remember converse, we did an if-then statement in number 2, and we're just going to flip it. Okay, so let's go back to my if-then statement in number 2. Too far. All right, here is my if-then statement. I'm going to copy and paste it to help us out. So, if a triangle is isosceles, then the base angles are congruent. Okay? So a converse of that is to flip it. So I'm going to say if the base angles are congruent, I'm going to abbreviate that. If the base angles are congruent, then, that's a comma, then the triangle is isosceles. Okay? So again, a converse is just saying it backwards. Okay? So first we said if a triangle is isosceles, then the base angles are congruent. The converse of that is if the base angles are congruent, then the triangle is isosceles, and yes, that is always true. Okay? So the converse is always true. All right? Okay, guys, you're going to try 9, 10, and 11. Press pause, and then I will go over the answers. So see if you can try 9, 10, and 11. Number 9. So Carly said, if an isosceles triangle is obtuse, then the obtuse angle has to be the vertex. Is she correct? Yes, she is correct. So we know triangles have to be 180 degrees, okay? So if a triangle is obtuse, that means one angle has to be more than 90, okay? So for example, 100. If you have 100, you can't have another obtuse angle in a triangle because 100 and 100 is 200, and we've already taken all of our points away for a triangle, okay? So you can't have two obtuse angles in a triangle. It's physically impossible. Look, I tried to make an obtuse angle here and an obtuse angle here, and I did not get a triangle, okay? So if you have an obtuse angle, it's got to be the vertex, okay? Because I cannot have two large triangles. All right, number 10, an isosceles triangle is a triangle with at least two sides congruent. Using this definition, what other type of triangle could be described as isosceles? So keyword is at least two congruent sides. What if it has three congruent sides? Well, hopefully you remembered three congruent sides is called equilateral. So an equilateral triangle is technically an isosceles triangle as well, because an equilateral side or triangle has three equal sides, and isosceles only has to have at least two. Okay? So an isosceles triangle is not an equilateral triangle, but an equilateral triangle is an isosceles triangle. Because to be isosceles, you just need two the same. All right. Last but not least. You have a triangle ABC. I hope you drew a picture because we have to draw a picture. Okay? So I drew a triangle A, B, and C, and it said my base angles are A and C because it said A was congruent to C. Then it gave you sides. So I hope you labeled your picture, and I hope you wrote this information on the outside of your triangle because it is sides. Okay? Hopefully you knew that AB was congruent to BC because in an isosceles triangle, if your base angles are the same, then these are going to be the sides that are the same as well. Okay? So this is what your picture should have looked like to help us out. So then I wanted me to determine all of the lengths of the sides. Now to start off with, I don't need all of them. I only need the ones that are congruent. So since these are my congruent sides, I'm going to set them equal to each other. Okay? This base angle is not important right now. Okay? It's only important at the end. So after you say 4x plus 25 equals 2x plus 45, when you solve this equation, variables on both sides, you get x is 10. Okay? So if I want to find the lengths of the sides, I then have to substitute in. Okay? So here's where my base angle or my base side comes in handy. So I had to substitute 10 into all three of those. And remember, substitution is parentheses. So I got 65 and 65 for these two sides, which is awesome because they're congruent. And then my base side is going to be 15. Okay? So when they give you sides, this is not like angles, and I would say this plus the bottom equals 180. So 180 is only the inside of the triangle, not the sides. If it is sides, they are always going to be equal, and you just have to figure out which two sides are equal. Okay? All right, you did it. Thanks for watching this video on isosceles triangles. If you have any questions, please let me know. But remember, isosceles triangles, two sides the same, base angles are the same, vertex at the top. Draw a picture to help you out. Now you can practice. Thanks for watching.